So last time I gave you a decimals of a foot handout. It's handy if you don't necessarily have calculator or whatever. And sometimes you get engineering drawings that things are in decimals and you had to convert back to fractions. So it's just handy to have. Typically, most of the time, you're going to run across 1 through 12. The thing with decimals is, they don't work very well with the fractions because a lot of them are repeating decimals. So like 1 inch is actually 0.08, and then 3.3 continues forever, but then 2 inches is 1/6, and 6/6 continues forever. 3 inches is actually 0.25, 4 inches is 0.33, and these are decimals of a foot. So that would continue. So a lot of these are repeating decimals. 5/12, 4.166, repeating. 6 inches is 0.5, 7 inches is 0.5833, repeating. The 3/3s repeat. 8 inches is 0.6, keeps repeating. 9 inches is 0.75. 10 inches is 0.8333. The 3s repeat. 9.166 for 11 inches. The 6s repeat. And 12 inches is equal to 1 foot. And then for fractions of an inch, 1/8 is 0.125, 1/4 is 0.25, 3/8 is 0.375, 1/2 is 0.5, 5/8 is 0.625, 3/4 is 0.75, 7/8 is 875, and of course 1 inches is what it is. So occasionally you'll have the whole numbers plus the fractions, and so basically you have to divide it by 12 to come up with a decimal, which is what this chart helps you with. We're not going to really do it in here, but I don't know what you can see why that would cause some issues, because basically if 2.8 is 2.666 and it's repeating, and 4.2 is 4.166 and repeating, and 6.6 is 6.5, well, if you add that up, what you're going to have is not an accurate conclusion because of the decimals over here. So what is that? 12 and 1/12 is, what is that? 12 and 1 is 13, and then that's 7, 8, and 13, and 6, 7, and 13. So you get something like 13.332, which is, is off as far as the actual number. If you just take these numbers and add them separately, 2, 4, 6, and 6 is 12. 8 and 8 is 16. Well, 16 inches is more than a foot, so you would have to adjust. So the actual dimension is 13.4. This really, to be 4, needs to continue that 3 repeating. So over a cumulative, especially with a lot of dimensions, if you're having to do this, you've got to adjust and round as you need to make it come out right. So it doesn't really work that well. For many years, we didn't have a calculator, handheld calculator that you could get dimensions added up on. In AutoCAD now, you can actually add this up and it'll work just fine. And you do have calculators that will do this for you now. But at one point, they really didn't exist, or if they did exist, they were very expensive. So the way I learned about it, I worked with a guy who went to Rice, and it's called the rule of 988. If you put the feet in the thousands and your inches over here, and then add 988 to it, however many times you need to, you can come up with the right number without having to have a dimensional calculator, which is interesting. I'll show you what I mean. Anyway, close that. So if you do the quick calculator thing here, and this didn't always work as far as the way I'm going to show you different things, but if we use those same numbers, 2008 that I was using for 988 and 4002 and 6006, yeah, it comes up with the same numbers I came up over here, but if you add 988 to it, there's your 13.4, which is the correct answer. So it was a way to use a handheld calculator that wasn't a dimensional calculator and be able to come up with the right dimension, but just adding an extra step. Since those days, AutoCAD has actually added to this to where you can actually just type things in. So 2 feet 8 plus 4 feet 2. Got to still add the feet mark. Plus, what was the other one? 6 feet 6. So these days, if you can just have access to AutoCAD, you can just type in the dimensions and you can get them to add up. So there are different ways to do it. The basic idea is that you want to make sure everything's adding up. Best practice is always to go to the same side of the wall. We don't even do that in these dimensions. But if you go to the same side of the wall, it's just easier to add things up and make sure things are adding up across the plan. What I mean, same side of the wall. So you would dimension, if you dimension this wall here and then this wall there, you would keep dimensioning to the same side of the wall across the plan. It's just a better way to do it. But there are exceptions even in this plan. And because this is an actual frame wall dimension, it's not that big a deal. But if you're using nominal dimensions like 4 inches and 6 inches for walls, then it gets to be a little bit bigger, because for like bathtubs it's 5 feet, but if you're using 4 inches here and 6 inches that way and you're dimensioning over both walls, you get 5'10", but that's not the correct dimension, because it'd actually be ½ an inch less on both sides, so it's actually 5'9". So it's a little more critical to dimension to the same side when you're actually using nominal dimensions as opposed to actual. We're using actual, so it's not as big a deal. At any rate, typically the way you dimension a plan is you would have the overall dimension total for the frame, and then you have any major projections. Major projections, like, you know, this would be considered a projection, that's a projection, that's a projection, and so you'd have all those, and then you would have the walls, and then the last thing you would have would be anything in between, like the doors and the windows. So it's kind of a, there's no hard and fast rule on dimensioning for that, but that's kind of generally the way it's typically done. So, come back where we were here. So let me drag this over. So first row of dimensions, basically the closest to, we'd have the openings in the doors. The next would include all walls. The next would be the major wall projections. The next would be the overall frame of the house. And then finally, if you had masonry, you would include the overall masonry as well. So that's kind of the way, like I say, there's no hard and fast rule to that, but that's kind of the way it's generally done. The dimensions we're going to be putting on A1 anodims for the layer, that's the layer it will be on. And we're going to use a 12-inch spacing between dimensions. Typically you're about 6 to 8 feet out from where your plan is for your exterior dimensions as far as where the first one belongs. That's not a hard and fast rule. It's more that you want to miss any major notes and stuff so you don't get into a conflict between the notes and the dimensions. And more often than not, you dimension it first before you put the notes in anyway. Alright, so using the grid, we can snap to the grid using the 12-inch spacing, and it's a lot easier than trying to eyeball it after the fact. So you could type in grid, it's also F7, but the spacing should be set to 12 inches. It should automatically be set to that unless you changed it for some reason. And then the snap, which is different than object snap, the snap should be set to 12 inches as well. This will help us dimension. Now, it's one of those things that you want to turn on and off as you need it. You don't want to keep snap on as you're doing all the dimensioning because it really gets in the way. And even the rules I just gave you, this plan doesn't necessarily follow everything down to the T on that. So just follow the plans that are on the, follow the dimensions that are already on the plan. So the way this would work is F7 is grid, and you can kind of see it come on there. It's also this same thing down here. F7 is grid mode. So you want to be able to see the grid. And so maybe you want to do your overall first, and so you want to use a linear dimension, and usually it's better if you go to annotate and start there and linear. This particular style we're using, annotative 96, is one that I set up. It has, you don't, this should already be set up, but it has certain requirements. The text is green, text height is 11/256. That actually is a derivative of something that's close to 4/96 or 1/8 of an inch high. It's 4 inches high in model space at this high, or it's close to being 4 inches high. That's where it comes from. But 11/256 is right. It is an annotated scale at 1/8 of an inch, and so it's going to be fine with that. And our precision right now is set to the 1/16 of an inch. That's already set up, but that's where all those requirements are set up at. Anyway, to do the first dimension, you would take the linear and you would make sure that your object snaps are on and you're going from your intersection or endpoint there to your intersection or endpoint here. And then you want to be, 4 to 6 feet out. Like I say, that's not a hard and fast rule, but this distance on this grid is 12 inches between the squares there. So right now, see, this is not snapping to anything. If you use snap at this point, like F9, snap back on. Okay, hold on here for a second. I know what happened. F9 turns off. No, it's actually still recording. I think it must be F10 that turns it off. All right. Apparently it's not working very well, but you can use this down here. I don't know why it's not working up here as far as the F9. Usually that works. All right, but anyways, object snaps are on for this, and then to snap to the grid, turn the snap back on temporarily so you can snap to the grid and keep it 12 inches apart. Once you've got it where you want it, then turn it back off because it really gets in the way, and then you want to do a continue. And in this particular case, we're going to go to the column, and to the other side of the column edge there. And then the next one is all the way out to the end. And just enter that to complete it and escape. And then you would start with the next row. Linear. Make sure you're going to the frame wall. This is to the midpoint of the window. And then to get it to that 12 inches apart, you would turn your snap back on and then turn it back off. Snap is, you only want to use snap temporarily to locate the dimension line. You do not want to keep that on all the time. You do want your object snaps on all the time. Continue. And this one's also going to the wall first. It's the wrong side, so it should be to this side. 8-2. And then we've got a 3-2 to the middle. And this is coming to this frame, and then the next one's going to the midpoint of the door and there. And then on this side, we're going to the wall first here, and then all the way out to there. Enter that, and then we're going to use the last row here. We've got the row over here. This is getting a little bit close, but I'll show you how to fix that in just a second. Make sure you're grabbing the right intersections. Turn my snap back on here for a second. Snapping to the grid, and then I'm going to turn it back off. Continue to here, and then to the door, and then on across, and then just enter. Alright, so a couple of things. I went to this intersection when I was doing that instead of the column. They're actually in the same line. This is going to obscure some stuff through here, so it would be better to have the dimension node coming off from there, so we'll have that gap for the dimension line. This is also a little bit close. You can use stretch to move everything at once. Stretch works by crossing the endpoints. Stretch is here. So if we come all the way across there, and we're already on top of the grid, and we know they're a foot apart, so if we want to come out maybe 2 feet more, you enter that, fix them point out in space. As long as ortho is on, you can type in how far you want to go, and you can stretch them all at once. So just follow the dimensions I have on the handout. And then you want to do your other direction here. You just still want to start with your overall, which is the 51.9. Otherwise, what I'm thinking about it, this is on the steps are on the level layer, and they're 12 inches each, and they're 7.4 wide centered between the columns. Anyway, for the dimensions, you're going to start not at the steps, but at the major frame wall column there. Still going to be linear. Don't be afraid to zoom in and out as you need to. You still want to line this up, snap it to the grid over there. So you can always stretch it after the fact if they're too far or too close. And then we'll go to the next one and take that back off. So the next one's going to be the 8.3 to here, and you're dimensioning to the frame wall, never to the siding. Because the frame wall size is not going to change, the siding might. Taking the snap off, then I'm going to do a continue, and I'm going to the entire house, which is 39 feet. And then column there is 4'6". Then I'm going to go back and get the major projections. Turn my snap on temporarily so I can get this. So I got to have the other end. I can't do it that way. Okay, I've got to actually turn the snap off. I've got to actually have a dimension to be able to snap it to the grid. So that first one's 15 feet. Now I can snap it to the grid. I've got 13 feet. It is 13 feet. Okay. Snap it. And then take snap mode off and then continue. That's the 15 feet. Enter that. Yep, I went too far, or I didn't pick up an inch dimension there. Alright, so you can, if you do what I just did, you can grab it, just grip it, take the dimension node here, and then put it in the right place. And in this case, it's going to be there. And then you just have to do that. So you can always grip the dimension and move it. But you notice how I'm tying the nodes to the object lines on the house every time. Start a new linear dimension, go to the midpoint here, snap it into place. Okay, went the wrong direction. Let's delete that. Let's try again.